We had a problem with our blueberries this year. Well, we're still picking them, and I don't know whether it was extreme heat or not, but we picked them. And then when we pick in a bucket, and then we spread them out into like a bin, almost like we use what they use in restaurants for dirty dishes, those types of bins. And we found that they'd be soaking the next morning. And I don't know if anybody else experienced that, but what has worked for us is we bring them in, the packing shed is air conditioned, so we pour them into those bins and then we just leave them at room temperature for several hours. And then we put them into the cooler, and that seems to have solved the problem. I don't know if anybody else was experiencing that. So I think it was the sudden change of temperature that caused the water to separate out or condense, I guess.
Steve, that sounds right to me. And I think I saw Jason Bolton and Hobb on the call from UMaine, and they can talk probably a little bit about some of the common practices in at least low bush. And I know they tend to have a resting period before going into cooling.
Chris, this is George Hamilton.
Yeah.
What he's doing is he's pre-cooling before going into the final cold temperature to get some of that field heat off. So you get that field heat off, you're going to be reducing some of that moisture content that was going to collect on those berries.
Yeah, I mean, it was soaked, but that seemed to solve the problem. Thank you, George.
Also, I just pasted in a link to another option that can help with that. It's actually a pretty low-cost approach called forced air cooling. So you could augment that by pulling air over the berries as well and speed that step up, George. So that's in there too.
One thing to think about field heat too, like in that case with the blueberries mentioned, is just this intense amount. You know, blueberries are probably 80–90% water, and so there's even through the skin this evaporation of the water coming out, and the density of water molecules coming off that surface is way too high to be picked up by that cold little kinetic energy of the air in the cooler. And so it's just going to condense all over that blueberry as it evaporates off, doesn't even make it off the surface barely. And that's what that room temperature thing is going to do, that stepping stone.
Also very high respiration rate in berries, right? So there's a lot of heat coming off compared to the mass of the fruit.
Also, with the berry being dark color, it's going to keep and hold that heat for longer than compared to even some of the red fruit.
It always surprises me as to how warm those buckets are.
Hobson's saying in the chat box that he's seen the same technique used with wild blueberries here in Maine, and that day cooling to room temperature also helps with damage when going through the sorter.
Yeah, respiration is another key factor, right? But we didn't, well, you talked about some, Chris, but that definitely can play a role.
It's a huge part of this, and you know, and it's not something that's often considered by most refrigeration contractors, believe it or not. So, you know, when you have conversations with folks who are doing refrigeration work, it's really important to reinforce that you're storing produce and not packaged food. So that respiration is a big part of that, as is humidity management.
Worked with several growers down in Pennsylvania where they will have a cold storage room maybe in the 55–60 degree range and bring the fruit in for one day into that room, then move it over to a final room just to try to break down the heat and have maybe more than one room so that you're dissipating that moisture out over many rooms, not just one room. So helps reduce some of that moisture.
That's been very helpful. Thank you.
Thanks for the question, Steve. There were quite a few questions earlier. I just want to make sure everybody feels as though they had their questions answered.
I have a question for Vern and for Hans, if Hans Estrin still on. Oh, there you are. Have you been aware of any LM testing on farms? I haven't. Do you know of anyone doing that?
No, it's not my area of expertise, but I just wondered since you were talking about it, if it had happened in New Hampshire.
I haven't heard of it either, except if there's a reason, and either FDA or someone might come in and test.
I mean, back in the day, they used to test the milk in the bulk tank on dairy farms before it went for processing. That's the only listeria testing I'm aware of.
There is an initiative out of the FDA called the Produce Safety Research Consortium, and that one of the things they're looking to do is actually get further upstream and understand what the sort of baseline conditions are in lots of different environments, including growing environments and storage environments and post-harvest handling environments. That's a research initiative that's arm's length and blinded from the FDA, so they support it, but they don't know where the samples are coming from. So that's underway, and they're interested in doing more of that work in the Northeast. It's generally been focused in other parts of the country, but as part of NECAF's work, we're actually talking with the FDA about hosting that initiative in the region as well. So another example is high tunnels. Speaking of condensation, so trying to understand what's going on there.
I do have a question. Amanda Kinchler gave a talk at one of the New England veg and fruit meetings about quick tests for various pathogens, and some of them relied on proxy organisms. But is there anything a grower might be using in their cold storage or elsewhere to take swabs to just understand the general extent of bacterial populations?
I would defer to Mary or Jason or Hob on that. If you guys want to talk about ATP.
Yeah, that's something I need to learn more about myself. I know right now we're focusing on just doing the things that will reduce the risk of bacterial contamination on the farm in the processing environment. So I think first you do that, and then you do testing. So first you make sure you're doing things right to reduce the risk of bacteria establishing itself in your farm, especially in the food processing and packing areas. But that's probably coming down the road, but it's not down our road yet.
Fairly common practice in food processing plants to do ATP swabs, looking for ATP, adenosine triphosphate, as an indicator of pathogens. But pretty rare in our region on farms and packing sheds, but it is used in other places. The thing to be prepared for is what to do when you find something. So why are you doing the swabs, and what would you do if you found something?
And do ATP is that is a very short-lived molecule, about 45 seconds in the environment. So it definitely would tell you that if something's living there, but is it a pathogen? I guess those would also, it's more just a proxy of that you got bacterial growth.
It's really, it's intended to be a validation step for your cleaning and sanitizing process.
Also, sorry.
Go ahead.
Hob must not have audio right now. He's saying in the chat box that ATP can get tricky on produce farms since produce is alive and will shed ATP.
Right. So this is really meant to be a way of, after you've gone through and done your cleaning and sanitizing, it's a way of confirming that what you did what you thought it did, clean and sanitize. So are you not only removing pathogens, but also any plant matter?
Right. And so then I would assume that the point Hob is trying to make is that since the produce can shed ATP, it could be befuddling your results. So if you're using the ATP test to find out if your cleaning and sanitizing is working and your produce is basically contaminating your results, then you're not going to get the answer. You might not get the answer you're looking for.
If that's a probable scenario, and I think where it could be used is, say you're cleaning and sanitizing the cooler floor, and then there's no produce that is in contact with the floor. It's all in bins, and you could swab that, right? And if there's no ATP production, that pretty much can tell you there's very little bacteria on that floor.
Yeah, drains, food contact surfaces on, handling equipment, that sort of stuff.
I think Hob is agreeing with you guys. He's got some microphone issues, but you must have expanded upon his points the way he wanted you to.
He's probably got a biofilm on his microphone. It's impeding its functionality, but I'm not advocating for this at all, but I was thinking, like, especially in a food contact surface, right? You've finished your season, you've got your bins, you clean them. You'd like to know that they're not harboring bacteria before you load them up again.
It does look like we have a few more minutes left if anybody has any additional questions for any of our speakers. And if not, I guess I will just say thank you very much, everyone, for joining us. And thanks to Paul and Mary and Chris and Andy for presenting. And if anybody wants to add their contact info to the chat box in case people think of questions tomorrow, that might be great. Otherwise, also keep your eye out. We'll send an email around when we have a recording for you.
Thanks, Heather, for having us. And thanks, everybody, for great conversation.
Thanks, Heather.
Anytime.